My name is Curtis Vanderschaft, and this poster is about developing a simple longleaf pine plantation growth and yield model for the Gulf region. Most of you are aware that the longleaf pine forest ecosystem was dominant and of the efforts to reestablish this ecosystem on the landscape. And this map here shows the Gulf region. FIA data was obtained from this region and used to fit models using these panels from the states of Alabama, Florida, Louisiana, Mississippi, and Texas. So basically the Western Gulf region and then the Eastern Gulf. And many of you are probably familiar with the FIA sampling design. So there were two kind of methods and four approaches, where methods and approaches are basically in many ways semantics. When using many observations of forested stands varying in age at the same point of measurement time, cross-sectional data, one of two methods are commonly used, or at least could be used. So one is to predict future yield from a single equation based on calibrating, quote unquote, the equation using currently observed yields, such as we see in figure 2. So we can use common growth equations, and we estimate parameters, and we have kind of the linear regression trend. And then we have an observed value from a stand or a plot. So we basically then just adjust up or down that linear regression equation to that behavior at a particular age for that plot or stand. And then we assume that the linear regression shape is going to be constant throughout time into the future. And one way to do that is using volume. So you have this equation to predict volume, and then you have an observed volume at an age, and you, in a sense, quote unquote, calibrate it. Then another method is to do the same thing, but instead of volume, you use, say, another variable highly related to volume, such as basal area. You have your basal area equation, and then you calibrate that basal area equation based on an observation, and then you predict volume as a function of basal area. For this study, approach 1 predicted volume simply as a function of age, and approach 2 predicted volume as a function of age and included a measure of dominant height into the equation. And despite longleaf's timber value, only a few growth and yield models have been developed for this species. So the objective of this study was to examine the ability of these modeling approaches to estimate marginal volume per acre of longleaf pine plantations in the Gulf region, to see if FIA data could be used to develop a tool for prediction. Equations were selected based on both biological and statistical considerations. Observations were eliminated from the original data set due to reasons such as young age, less than 5, illogical observations. One plot had a dominant height of 45 feet at age 8 for longleaf. That's if longleaf could only grow that fast. Low number of sample trees within a plot, say 2 or 3 trees. So therefore, the final model fitting sample size was 47. So after model fitting, validation was conducted using 4 independent data sets, published data sets, to gain insight into which approach would produce the most accurate and precise estimates. So one is from southern Mississippi, Schmidtling, 1984 and 87. Diameter and heights were measured at ages 8, 25, and 39, and therefore volume could be predicted. And Farrar and White, Alabama, where the initial measurement ages were 7 and 8, and the predictive ages were 10 and 11. And then 2 other studies from Georgia, where the initial measurement ages were 7 and 9 for one site, and the second was 17 and 21, and the second was in Oldfield. It is somewhat difficult in FIA to distinguish between Oldfield and cutover sites. The results show under predictions at age 25 using age 8 as the the initial measurement age or the calibration age, and age 25 to predict age 39. However, these are extremely long prediction intervals, 8 to 25 and 25 to 39. At the Alabama site, approach 3 also produced the best results. However, there was a slight overprediction, and actually results may be acceptable by users at this site using approach 3. Or you could say for conditions similar to this site At the two Georgia sites, approach 1 actually produced the best results. It is difficult to recommend a particular approach because approach 1 worked best on one site, approach 3 worked best on another site.